Here we go, kind of the second half of the trig unit. This is going to be solving for missing angles. So we talked about how to solve for missing sides yesterday. Today we are going to solve for missing angles. So solving using trig to solve. And remember that with triangles, we still are playing with 180 degrees. That hasn't changed. So if you know a 90 and one angle, you can use supplementary angles to find the measure of the other one. And the deal you're going to have to do to solve for a missing angle is to use inverse trig functions. Okay. Inverse trig functions. I'm going to go grab my calculator. So, what's an inverse trig function? Wheel. If you look right above your sine button on your calculator, you're going to see these green sin minus 1, cos minus 1, tan minus 1. Those are your inverse trig functions. So sine minus 1 undoes sine, cosine minus 1 undoes cosine, and tan minus 1 undoes tan. Okay? Just kind of like square undoes a square root. That's what these guys do. Now I'm going to show you a couple of examples with these guys, how they work, maybe one of each type. But they're all going to kind of work the same way. Okay? And again, with these ones, we're going to do a few examples in our notes as well as together in the examples video. So first one, let's take a look at this guy. If you have an x, an 18, and a 6. Well, here's the guy we're playing with, right? We're missing that angle. So we're going to label the triangle from this angle. Hypotenuse is always across from the 90. That's opposite. That's adjacent. Which trig function? So, ca, or to. We're playing with opposite and hypotenuse. That would be so. That's the guy. So we go sine of our angle, which we don't know, equals opposite 6 over hypotenuse 18. Okay. Now I recommend leaving that as a fraction. You could reduce it to 0.3 repeating, but the problem's going to work easier if you leave it as a fraction, because what you need to do is get your x by itself. Well, you got this sine acting on it. And how this looks, you might be like, well, I'm going to divide both sides by sine. That's not how you can do it, okay? Because this is the sine of x. You're doing a sine function on x. You're not multiplying sine by x. So you have to take the inverse sine, and what you do to one side, you must do to the other. Okay? So you take the inverse sine of both sides, and the sines by the x will cancel. So we have x equals inverse sine of 6 over 18. You could reduce that. You don't have to, though, because you're going to just pop that into your calculator. So secondary function, your sine button. Now you'll see a little sine minus 1. 6 divided by 18. Oops, I'm sorry. 18. End your parentheses, and boom. 19.47 or 19.5, depending on how we're rounding. Boom, done. Number 2. For the x, a 12, 15. We're going to do the same thing we did up top. We're going to identify the angle we're starting from. And we have to find the opposite, adjacent, hypotenuse. Opposite right across. Adjacent between your angle and 90 and hypotenuse is across from the 90. A and H, that would be ka. Cosine equals adjacent over hypotenuse. And that is what we are working with right here. So now we go cosine of our angle equals adjacent 12 over hypotenuse. And from here, it's algebra time. Inverse cosine both sides to get our x by itself. So x equals inverse cosine of 12 over 15. And again, you really can't use these without a calculator. Okay, you cannot use these without a calculator. You could use a cell phone calculator, but I highly recommend just getting a scientific one so you can get used to using it. And I'm getting 36.9. Boom, baby. And last but not least, número 3. Oh, man. Let's see what we got here. We have a 19, 22, and x. So we label our pieces. Starting from here, there's my hypotenuse. Hypotenuse always across from your 90. Opposite across from your angle you're playing with. Adjacent between your angle and the 90. And that would be opposite and adjacent we're playing with, which would be TOA. Okay. So we go tan of our angle equals OA, opposite over adjacent. And from here, we need to get our x by itself, so we take the inverse tangent of both sides. So x equals inverse tangent. 22. And from here, put that in my calculator. Inverse tan of 19 divided by 22. Boom. I'm getting 40.8. Bop, and I'm done. That's it. So we'll do a few more examples of these together, but that gives you the kind of the gist of it. Again, having these guys in your notes is going to be helpful, and check out the examples for more examples. Thanks for watching.